You know those rather rare moments in life when you've just finished a project that took months, sometimes years, to complete. Something that involved the work of about 10 people, and you finally see the end result, which honestly makes you proud. Well, that's exactly where I am right now. We started uploading a podcast. It's called La Nouvelle Odyssée de l'Espace. We talk about space exploration on Spotify from the 1950s to today, and even what the future might hold for us. Anyway, I won't spell it out for you because it's something you listen to. There's nothing to watch, just to listen to, with music and immersion. Those who are making and have made the history of this adventure happening just a few hundred kilometers above our heads. In fact, go for it with your eyes closed. But first, make sure you log in, otherwise it's really a hassle. Because Paradiso Media, the team behind this project, did an amazing job. I'll put the link here, at the end and just below. I really hope to see you there. With that, I'll leave you with the sounds of Mars, and with the person I was 3 weeks ago. That's one small step for man.
One giant leap for mankind. That's one small step for man. One giant leap for mankind.
You just heard a simulation of how Armstrong's famous quote would sound to the ear when he first set foot on the surface of the moon. If he had said it without a helmet on the surface of the planet Mars, a preview of the sense we are going to focus on today. Open your ears wide, because after listening to the little music of the sun in the previous episodes, then that of our magnetosphere of Saturn and of Jupiter, today we are going to listen closely to the surface of other worlds. This time, solid planets, as well as satellites on whose surfaces we have made surprising recordings. And with the exception of a few simulations, all the sounds you will hear in this episode were captured as closely as possible, directly on site, from the surface or, in rare cases, while we were trying to get there in space. These crackling sounds, over which you can hear the subtle noises of the Perseverance rover's instruments being checked, were recorded while it was traveling encapsulated in its spacecraft heading toward the red planet. And at that time, it was several tens of millions of kilometers from Earth, plunged into the cold and silent solitude of interplanetary space. And here we are a few months later. Your speakers are now playing the very first audio recording made on the surface of Mars. The rover had only landed 18 hours earlier, and the mast to which the microphone is attached had still not been deployed at that time. The recorded sounds are slightly muffled, a bit like the sounds you hear inside a seashell disturbed by the electronic buzzing noise, a seashell opening onto another planet. 3 days later, on this other recording, listen closely, a bit of wind can barely be heard. It's worth noting that on Mars, the thin and sparse atmosphere is nearly 100 times less dense than that of our planet. And so, sounds carry much less easily there, to the point that noises are muffled and filtered. Their range is reduced there, but that won't stop the Perseverance rover from arriving nearly a month later. The very first spacecraft to land on another planet recorded the sounds made by another spacecraft besides itself. Listen carefully. You should hear above the rustling of the winds the sound of the tiny helicopter named Ingenuity, the first object to fly on Mars, which was 80 meters away from the rover at the time of this recording. Here on the surface of the red planet, the sounds of the helicopter blades, which spin at nearly 2,500 revolutions per minute, are greatly muffled by the thin Martian atmosphere, which makes it difficult for them to travel. And since we know precisely the pressure, temperature, and composition of this atmosphere, we can have fun comparing the differences between the sound in this strange environment and ours here on Earth. For example, we know that in the cold atmosphere of Mars, sounds travel slightly more slowly than they do here on Earth, with a speed of about 240 meters per second compared to about 340 on Earth. But mainly because the atmosphere there is made up of 96% carbon dioxide, high-pitched sounds are much more dampened and absorbed. So that a bicycle bell, for example, as heard here on Earth, would sound like this on the red planet. As for birdsong, it would be completely inaudible to human ears. The birds would be dead, but that's another story. And since I've already dampened the mood a bit, I might as well let you listen to another one. That of Venus, a celestial body that's even more inhospitable than Mars. Here, unlike the red planet, there is an astonishing atmospheric pressure on the surface, which is 92 times higher than that of our planet. And so sound travels slightly faster there, and it's in these hellish conditions, with temperatures around 460 degrees. In 1982, the heavily armored Soviet probe Venera 14 managed, during the first hour it survived on the surface, to take some pictures, but also, and most importantly, to make the very first audio recording from the surface of a world other than our own. Before finally giving out, crushed by the pressure, collapsed. You can hear the strange Venusian winds, which, although relatively slow at ground level, are clearly present there. Because here, in this atmosphere so dense you could cut it with a knife, the propagation of sound is greatly amplified, giving the impression of a powerful and constant background noise. But once you're at altitude, everything is different. In May 2021, the Parker space probe flew over the planet's highly charged upper atmosphere, detecting a natural low-frequency radio signal, which allows scientists to calculate its thickness. It's thought that thunderstorms often occur lower down in the thick clouds here. This otherworldly ASMR that you are hearing now, and the most distant audio recording ever made. Crafted by humans on the surface of a world other than our own, we have once again made a leap through space and time. Car cet enregistrement a un peu plus de 15 ans. And it was made some 1.5 billion kilometers away from us, on one of Saturn's moons, Titan. It's January 14, 2005, and 8 years after leaving Earth, the Huygens probe dives into the atmosphere of Titan, carrying an acoustic sensor on board. During its descent through the thick atmosphere made up of nitrogen, methane, and a large amount of other hydrocarbons, the probe collects audio data that will be sent back to our planet.
Here's a sample.
In this first recording, the characteristic humming sound that seems to speed up as time passes was created by converting some of the radar echoes received by the probe during the last kilometers of its descent into audible sounds. Here, the pitch and intensity of the collected sounds, which increase as the probe approaches the ground, will later be used like an ultrasound to learn a bit more about the mysterious nature of this satellite's surface. And in this one, the recordings were combined to create a more realistic rendering of what a traveler aboard the probe would have heard during its descent. Maybe one day we'll go back there to record the sound produced by liquid methane rains, which almost certainly fall from the sky there. And while the sounds from the last recording you heard were indeed edited, that's absolutely not the case for this one, which I'm going to leave you with. Here you are once again in the company of the Perseverance rover, which you can hear rolling across the surface of Mars. 16 minutes of raw and unfiltered sound from a journey toward Jezero crater, a journey taking place on another world. You can hear the very unpleasant noise, a high-pitched screech, most likely caused by electromagnetic interference coming from one of the rover's electronic units. And most importantly, the sounds of the suspension and the wheels in direct contact with the surface of another planet. And since you're still here, as a real conclusion, here's a reward in the form of Debussy's Clair de Lune.
Entendez actuellement jouer sur Terre
And now, here's what its melody would sound like on Mars. Subscribe, support me, share all this on Insta in whatever order you like. Thank you for listening to me.